Guys, welcome back. We're going to do Unit 11, Lesson 2, the Fundamental Counting Principle. In Exercise 1, we covered that in Unit 11, Lesson 6. So we're going to skip right down to the middle of the page, and we're going to talk about the Fundamental Counting Principle. So, at a cafeteria, a student can order the daily special for $4.99, consisting of one drink, one salad, and one entree. If students have 5 drinks to choose from, 4 salads, and 3 entrees, how many different choices do they have for the daily special? So the fundamental counting principle says that you take all the choices and then you multiply them. So there were 5 choices for drinks, there were 4 choices for salads, and there were 3 choices for entrees. So if I multiply 5 times 4 times 3, I get a value of 60. So there are 60 choices for lunch, for the daily special of lunch. Letters are to be chosen from the word hyperbola without replacement, which is important, to create a 4-letter code. Determine the number of these 4-letter codes that begin with 2 vowels. Here, Y is a vowel. So what I like to do is, I need a 4-letter code, and it gave me some restrictions. It says the 4-letter code that begins with 2 vowels. So these guys have to be vowels. And it says here Y is a vowel. So let's see, how many vowels are there? H, here's a vowel, vowel, and a vowel. So there are a total of 4 vowels. So I could choose H, E, O, or A for the first choice. This part right here says without replacement. So once I use one of those vowels, I no longer have it to choose from. So that means that this number of options drops down to a 3. And then the next ones, we don't really, doesn't matter, but without replacement. All right, so now this is where it might get a little bit tricky. So I have to pick another letter, and there are 9 choices to choose. There's 9 letters in the word hyperbola. I've used 2 of them already, so that means I have a 7 available here. And after I pick that letter, I have 6 to choose from. So if you multiply 4 times 3 times 7 times 6, you get 504. All right. Next page, it says consider the letters in the word cat. 2 letter codes are to be made out of these 3 letters without replacement of letters. List all of the different 2-letter combinations or 2-letter codes. So I could have a CA, I could have an AC, a TC, CT, AT, or TA. Calculate the number of codes using the counting principle. Well, right, I need a 2-letter code. I have 3 letters to choose from. It says without replacement, so once I pick one of those letters, I only have 2 left. So 3 times 2 is 6, and if you look to the left, 1, 2, 3, 4, 5, 6, there are 6. Write out each of the following, given in permutation notation, as an equivalent product. Evaluate the product using multiplication and use your calculator's permutation function. Well, my calculator is the old version, the old operating system, so I'm not going to use that. But if you have a newer one, you're going to hit the math button. You're going to arrow over till you get to the PRB key, and this time you're going to choose choice 2, and it's NPR. So if I didn't have a calculator, if I had to do this the long way, 8P3 really means 8 times 7 times 6, which has a value of 336. So it means that I have 8 objects to choose from, and I am choosing 3 of them. So, or I could write this as factorials, 8 factorial over 5 factorial. And that is a exclamation point, but in math we call it a factorial. It's not an 8 that's very excited to be here. It's called a factorial. 15P2 means that I have 15 times 14 because I want to take 2 numbers. 15 times 14 is 210. Again, if I wanted to write that in factorial, 15 factorial over 13 factorial. 4p4 means 4 times 3 times 2 times 1, which has a value of 24. And in this case, it's just 4 factorial. So if you notice, the denominators of these guys were taken by 8 minus 3 is 5, 15 minus 2 is 13, 4 minus 4 is 0, but we don't want to make the denominator of the fraction 0 because we know that causes some problems. 10 runners are entered in the 100-yard dash. How many different ways could the runners finish first, second, and third? Express your answer in permutation and as an integer. Well, let's see here. So I have a first place winner, a second place winner, and a third place winner. There are how many contestants? There are 10 contestants. Well, if one person comes in first, right, that person can also not come in second. That would be impossible. So one person is out of the mix. That means that there are 9 left for second place, 8 left for second place. So that is a value of 720 different ways the runners could finish first, second, and third. If we wanted to write that in permutation notation, it's like a tongue twister, I have 10 people, right? And I'm picking 3 of them. So you could also do it that way. Darla chooses 12 songs for her workout playlist. If she puts her MP3 player on a random, no repeat setting, in how many different orders could Darla listen to all 12 songs? Express your answer in permutation using factorial and as an integer. Well, 12p12, right? Because I have 12 songs and I'm picking all 12 of them, which is the same as 12 factorial, which is the same as 479,001,600 different ways she could listen to those 12 songs. And just a side note, 12 factorial really means 12 times 11 times 10 times 9 times 8 7 times 6 times 5 times 4 times 3 times 2 times 1. But it's much easier to write it as a permutation or as a factorial instead of writing all that out. All right, this was a nice quick little lesson, so hopefully you guys have a better understanding of permutation notation and the fundamental counting principle, which really means you're just multiplying the number of choices that are available. Thanks for tuning in. Have a good night.